Hi everybody, Mrs. Danielson here, and today I'm going to introduce you to your Pythagorean identities. These are brand new and pretty easy to use. Let's go ahead and get started. I'm actually going to show you some alternative choices to the Pythagorean identity as well. So let's go ahead and get started with our Pythagorean identities. Right here, you can see 3 Pythagorean identities listed. You have choices when you're working with your trig identities. The most common one is the one on top, sine squared plus cosine squared equals 1. That's going to be the one you use the most often, but you do have 2 other choices when you're working with your Pythagorean identities. Let's go ahead and start using these. What's great about the identities is that they have been proven by somebody else. Somebody else went and did all the work of proving that these were true. They're fact, they're proven. That means you can just take identities and just put them in your toolkit, pull them out and use them whenever you want to do your math, and you don't have to worry about whether or not they're accurate. They've already been proven by mathematicians in the past, and now they're just tools for you to use. So these are 3 new tools for you to be able to work with in your pre-calculus. So what is a problem you would use these for? Let's say you're given the problem that cosine is 3/5, and you want to know what sine is if your angle is between 0 and 90 degrees. Okay, so you have cosine, you're given sine. That means you're going to use that first Pythagorean identity because it relates sine and cosine. Okay, so you would take your first Pythagorean identity. Let's just rewrite it for reference here. Use that first one because it relates the 2 things we're interested in, so it's the easiest one to use. And we're just going to plug in for cosine 3/5. Okay, we're solving for sine. Plug in 3/5 here, and then solve for sine. Okay, so cosine squared, that's going to end up being 9/25. Okay, you're going to subtract your 9/25 from the other side, so 1 minus 9/25. That would be 25/25 minus 9/25, or 16/25. Okay, so now just take the square root of both of those sides. You'll get plus or minus the square root of 16/25, which is going to be plus or minus 4/5. So that means you have 2 answers for sine, right? Is it positive 4/5? Is it negative 4/5? So for that, to decide which one, you're going to use that information it gave you that the angle is between 0 and 90 degrees. So it's in quadrant 1. And remember our rule, all students take calculus that tells you which quadrant has which positive trig functions. So in quadrant 1, which is where we are, all trig functions are positive, okay, including sine. So that means our answer is going to be the positive version, positive 4/5, and you have your answer, okay, 4/5. Okay, so that's an example of using one of your Pythagorean identities to solve for something. Okay, those are the easiest ones where the 2 things you're relating are the 2 trig functions in the identity. Okay, let's do one more like that, where the 2 trig functions are part of the identity you're working with. Okay, if tangent is negative 12/5, and your angle is in quadrant 4 this time, what is secant? Okay, so we're relating tangent and secant this time, and our angle is in quadrant 4. Okay, so tangent and secant, this is kind of nice again, because if you look at our identities, that second identity relates tangent and secant. So this one won't be too bad because we can just plug into that one, tangent and secant. Okay, so let's rewrite our identity. Tangent squared plus 1 is equal to secant squared. Okay, it's nice when the two things you're relating are part of the identity like this. So you're just going to plug in -12/5 for tangent, and we're going to solve for secant. Okay, so -12/5, we're going to square that, 144/25. Okay, and 1 is 25/25, so when we add that, we get 169/25. Okay, now you're going to have to square root both sides, and you get plus or minus the square root of 169/25 for secant, or plus or minus 13/5. Okay, so now again, you have two answers, right? You've got positive 13/5, but you also have negative 13/5, so you have to figure out which one it is. So we go back to that rule, all students take calculus, and this time we're working in quadrant 4, right? It told us right here which quadrant we were in. Okay, that tells us that cosine and its reciprocal are positive in quadrant 4. Everything else is negative in quadrant 4. Secant is the reciprocal of cosine, so it's cosine or secant that are positive in quadrant 4. Okay, so we're going to pick the positive answer, and we're done. Okay, so that's not terrible to use that identity. It's actually pretty easy. You just have to do some squaring and take some square roots, and then you have to pick your sign based on the quadrant it's in. Okay, but what happens if the two trig functions you're working with are not the two in the identity? Okay, then it gets like a little bit trickier. Okay, so let's do one where that's the case, right? The two trig functions are not the same two in the identity. Okay, so say we're given tangent. Okay, we're given tangent, we're given the quadrant. Okay, so in this case, we're in quadrant 2. And we want to know cosine. Okay, so tangent and cosine is what we're trying to relate here. But we don't have a Pythagorean identity up here that relates tangent and cosine in particular, right? We want a tangent and secant, or cosine and sine, but not one that actually relates tangent and cosine. Okay, so this one's going to be a little bit trickier. Okay, what we can do is we have a Pythagorean identity that relates tangent and secant. And then secant is the reciprocal of cosine. So we can use that one and solve for secant and then take the reciprocal. And that's what we're going to do. Okay, now that can be a little bit of a lengthy problem. So I'm also going to show you another option for these cases where you can't just use the Pythagorean identity and be done, right? These ones are a little longer. I'm going to show you another choice, okay? But first, let's do the option where we are using the Pythagorean identities. Okay, so what we're going to do is we're going to use our tangent squared plus 1 equals secant squared. We're going to solve for secant, and then we're going to take the reciprocal. So it's kind of like a two-step process for this problem. Okay, your tangent is -square root of 5/5. I gave that information to us. And now we're going to solve for secant. Okay, so -square root of 5/5, when you square that, you're going to get 5/25. Okay, let's just simplify that to make our math a little bit easier. Okay, so 1/5 plus 1, right, would be 1/5 plus 5/5. So that's going to be 6/5. Okay, now we're going to square root both sides. Okay. So that would be, we're solving for secant, plus or minus the square root of 6 over the square root of 5. Okay, it's got a square root on the bottom, so multiply top and bottom by the square root of 5. And you get plus or minus the square root of 30 over 5. Okay, now we have plus or minus, but we do know we're in quadrant 2. Okay, and is secant positive or negative in quadrant 2? Right? Sine is positive in quadrant 2. Sine and its reciprocal, and the reciprocal of sine is cosecant, not secant. So that means that the actual one is going to be just the negative. Okay, so that's secant. We don't want secant though. What we're actually solving for is cosine. So for the final part of this question, we need to take the reciprocal of that. So it'd be negative 5 over the square root of 30. That's actually what we're solving for. But now look what we did. We went and put the square root in the bottom. So now we need to multiply top and bottom by that square root. So you would have negative 5 square root of 30 over 30, which simplifies a smidge to negative square root of 30 over 6. That is a lot of steps, but we got there. Negative square root of 30 over 6. All right. So we use the Pythagorean identity, right? And then we use a reciprocal identity to get to the final answer. Okay. So that was option 1. Now let's take a look at option 2. Okay, so for option 2, what we can do is we can take the given information and we're going to create a triangle and then solve for the third side. Okay, so we know we're in quadrant 2. So I'm just going to draw myself a right triangle in quadrant 2. And they've given me that the tangent is equal to negative square root of 5 over 5. And tangent is opposite over adjacent. So the opposite side of that angle is the square root of 5. And the adjacent side is a 5. But one of those has to be a negative because the tangent is negative. So which one is it? In quadrant 2, is the x negative or is the y negative? In quadrant 2, the x is negative and the y is positive. So I put my negative there with the x. Okay, now that's what they've given me right there. Okay, they want me to solve for cosine. And the cosine is adjacent over hypotenuse. So in order to solve for cosine, I just need to find the hypotenuse of that triangle. It's a right triangle, so I can find the hypotenuse just by using the Pythagorean theorem. Okay, so I'm just going to do negative 5 squared plus the square root of 5 squared equals the hypotenuse squared. Okay, 25 plus 5. So 30. Taking the square root. And I get plus or minus the square root of 30 equals h. You know, the hypotenuse, when you do this, is always going to be positive. It's never going to be negative. So I can go ahead and get rid of that. And now my hypotenuse is going to be the square root of 30. Now I have all three sides of that triangle, so actually they could ask me for any of the 6 trig functions, and I could find it really easily now that I have all 3 sides of my triangle. Okay, but what they want is they want cosine. Okay, so cosine is adjacent over hypotenuse. Now I have to multiply top and bottom by the square root of 30. So negative 5 square root of 30 over 30. And that gives me a final answer of negative square root of 30 over 6. And that's the same answer that I got with the other method. Okay, so 2 choices. You can use the Pythagorean identities if you want to, or draw a triangle and use the Pythagorean theorem to find the 3rd side. Okay, again, this is like maybe a good way to go, especially if you're having to use a Pythagorean identity that isn't the exact same 2 the trig identities that you have been asked for, like in this case, right? It didn't have tangent and cosine, so it meant we had to do a little bit more work. Okay, let's do one more problem. And what I'm going to have you do is, after we get the problem down here, I want you to pause the video, solve the problem, and then play the video again and see if you get the same answer as me. All right, so what we have here is we have cosine. They've given us cosine. They've told us we're in quadrant 4. Okay, and they want to know tangent. So how are you going to do that one, right? We don't have a Pythagorean identity that relates cosine and tangent, so you might have to get a little creative if you're going to use a Pythagorean identity. Or your other option is to draw a triangle in quadrant 4 and do it that way. Okay, pause the video and let's see what you come up with. Okay, so hopefully you have an answer, and let's see how it went. Okay, why don't we start by using method 2 from the previous problem. Okay, that's the method where we go ahead and draw out a triangle. In this case, we're drawing it in quadrant 4. Okay, and they told us that cosine is 3/5, right? Cosine is adjacent over hypotenuse. Okay, we want to know the tangent. Tangent is opposite over adjacent, which means we need to figure out the opposite side, which is going to be our y. We don't know that. Okay, so you may be able to just look at that triangle and know from working from right triangles what that 3rd side is. You might already know. But if you don't already know, then we can use the Pythagorean theorem to figure it out, right? And that would be 3 squared plus y squared equals 5 squared. So 9 plus y squared equals 25. Move your 9 to the other side, and y squared equals 16. Or y equals plus or minus 4. So which is it, plus or minus 4? Well, we're in quadrant 4, and in quadrant 4, is your y positive or negative? Right, in quadrant 4, your y is negative, right? So this is going to be a negative 4. Okay, we want to know tangent. Okay, so tangent is opposite over adjacent. So it's going to be negative 4/3. Great. Is that what you got? Hopefully that's what you got. Okay, but now how would you do this if you wanted to use one of our brand new Pythagorean identities, right? We don't have one that relates cosine and tangent. Okay, but we do have one that relates sine and cosine. So let's start there. We're going to solve for sine, and I'll tell you why here in just a second. Okay, so we're going to solve for sine. Plug in our cosine. Okay, so that's going to be sine squared plus 9/25. Okay, move that to the other side. That would be 25/25 minus 9/25, or 16/25. Take the square root of both sides, you get plus or minus 4/5. Okay. Now, tangent is opposite over adjacent. Opposite is your y, and adjacent is your x, right? We talked about that in a previous video. And also we know that y, right? Y is your sine. Let me put our angle in here just so it looks a little bit better. Y is your sine, right? And x is your cosine, which is also something we talked about in a previous video, but sine is your y and cosine is your x. This is also another identity right here. Okay, another helpful identity, which we can now use, right? Because tangent, sine we just now calculated as plus or minus 4/5. And cosine they gave us at the beginning is 3/5. Okay, that reduces to plus or minus 4/3. Okay, and again, we're in quadrant. Which quadrant are we in? We're in quadrant 4. Stop moving. All students take calculus. Tangent is not positive in quadrant 4, it's negative. So our final answer is negative 4/3, which is the same answer we got from the other method. Okay, and that is it for using the Pythagorean identities. Thank you everybody for joining me.